Hi, everyone, and welcome back. If you didn't get enough on quantitative analytics last week, awesome, because we've got some more on it this week. There's plenty of stuff out there on how to do analytics, how to run statistics, plenty of great resources if you want to learn the tactics of how to run them, how to do them. What's really hard, though, is knowing which analytics to run and when, and especially for your specific types of questions and problems. And so, just like how last week we talked more about the types of questions that you would ask to help drive your analytics approach, this week we're going to get into how do you know which analysis to run based on the question you're trying to answer. So, I'm going to run you through 5 of the more common analytics techniques and kind of let you stretch your muscles a little bit by giving you some business questions and seeing if you can identify the right analyses for trying to address those. So let's get into it. Number 1, chi-square. This is best for when you're looking to compare or identify relationships between two categorical variables. Categorical just means anytime you have groupings. So they're not necessarily numerical, but you can count them in groups. So let's say that you want to compare or look for relationships between customer age groups, like young, middle-aged, and senior. And you want to look at whether or not they have preferred product categories, like purchasing clothing, electronics, and appliances. Well, then a chi-square test is going to let you see if their purchasing choices are independent or if there's some kind of hidden pattern. So, for example, it might reveal to you that young customers buy more electronics. And so you're going to decide to use a chi-square anytime you're looking to connect categorical sets of data. Now, next up, t-test. These are great for when you want to compare averages of two different things. For example, if you want to compare the average delivery times of two different shipping companies, to see which one will deliver your stuff faster. Well, then a t-test is going to be great to see if there's a statistically significant difference between the two companies. T-tests are going to help you when you want to compare two categorical groups, company A, company B, but can also be things like pass, fail, attended, didn't attend, control group, experiment group, anytime you have two groups. And what it's going to compare is the average of some kind of continuous numerical value, like time or dollars or clicks or anything like that. Now, if you have two sets of numerical values and you want to compare the relationship between those two, well, then you can try correlation. So, for example, correlation might let you measure the strength and direction of the relationship between customer satisfaction scores and purchase frequency. If you found a correlation, it would mean that higher customer satisfaction is related to more purchases. If you found a negative correlation, that would suggest that higher customer satisfaction is related to fewer purchases, which would be weird. So hopefully you don't find a negative correlation. So correlation is, again, going to be anytime that you're looking at two of those numerical values and looking to see if they tend to move in a pattern together, either both going up at the same time or as one goes up, the other one tends to go down. Now, number 4 is regression. And let's just say that you want to predict something, like future sales in your organization, and you want to predict it based on multiple factors, like how much money you spend on advertising and the amount of social media engagement that your company receives. Regression analysis is going to allow you to do this by creating a model of how your dependent variable, that's what sales would be in this case, because it's the thing you're trying to predict or focus on, how sales is influenced by one or more independent variables. In our example here, the independent variables would be that advertising spend and all of that engagement data. And so when you're working with regression, it's because your goal is to try to predict or explain how much that dependent variable is being explained by those independent variables. And it does need to have data where your dependent variable is numerical and ideally continuous. So things like sales, time, clicks, anything that you can kind of count up. And the independent variables are either continuous in nature or, they can be categorical and other types, but they will need to be coded numerically. And actually, there are a lot of different types of regression. That last example would be what we'd call multiple linear regression because it has more than one independent variable. If it had only had one independent variable, we would have called it simple linear regression. And I bring this up just because I want to introduce you to another type of regression, logistic regression. This one is when you need to predict something, but the thing that you want to predict only has two possible outcomes. For example, customer churn. Super common, is trying to predict the likelihood that a customer will cancel their service. These things only have yes or no values. Cancel, yes or no. Purchase, yes or no. And logistic regression is an approach that lets you analyze the relationship between independent variables like past purchase history or demographics, and then predict a dependent variable that only has two options, yes or no. And then it gives you an estimate or a prediction of the probability of one of those two outcomes. So you're going to use logistic regression anytime your dependent variable, the thing you're trying to predict or explain, has a categorical and dichotomous or binary. All that means is that there's only two options, dependent variable that you're trying to predict. And then you want independent variables to be continuous or at least coded numerically. I do have to give a pretty strong warning, actually a huge warning. This is the point where if this was a commercial, I would have to run one of those warnings that just scrolls through the screen forever. Because I've given you a very simplified version of these and they only scratch the surface. Not only are there multiple variations on chi-square, there are multiple types of t-tests, there are types of correlations, types of regressions. There are also just tons of assumptions about what kind of data you actually have to have in order to be able to use one of these appropriately. And there are all sorts of other things that you should be using if you don't have the right kind of data for these. And oh man, the list would just go on and on and on. But hopefully this is just a nice starting point for you. And with this little bit of background, it lets us get to the fun and somewhat harder part of trying to think like a data-driven problem solver. So what I'm going to do is I'm going to give you some business questions, and I want you to try to think of which of the analyses I talked about here in this video that would be appropriately applied to answer them. So I'll only pause for a small moment after each question and you try to think of the answer. If you need a little more time to think, you might want to be prepared to hit that pause button. All right, you ready? Here we go. First question. Do years of experience, level of education, and performance review ratings really predict who gets promoted? And the answer is logistic regression. We know it's probably going to be regression because it says predict in there. But the logistic part jumps out at us because promoted is yes or no. You either get promoted or you don't get promoted. All right, next question. Is there a difference between customer location and their preferred type of restaurant? This one is chi-square. That's because location is not really numerical. It's either going to be a state, a region, a city, a street address, and same thing with type of restaurant. Might be a type of food, might be a style, something like that. So this would be two categorical variables, and chi-square would be best. Okay, next question. We sent half our subscribers an email with the personalized name in the subject line to see if more people on average would open that one. And now we want to know if it worked. That one's a t-test. It takes a little longer to know what we're assessing there, but breaking it into two, got the personalized name, didn't get the personalized name, and then would be comparing the average open rates of the emails to see if the personalized one performed better, got more opens. All right. Is there a relationship between customer satisfaction scores and the number of customer service representatives we employ? This one would be correlation. And by the way, it's correlation because yes, we're looking for a relationship and these are numerical values, but also we're not implying that there's some kind of prediction or some sort of order between the two, just that they happen to be related. Okay, last question. Does a customer satisfaction score affect how much they later choose to spend with us? All right, now this one is regression. You might have noticed that there wasn't the word predict, but we can get there because it has the word affect, which means that we think one of the variables has an effect or has an impact on the other one. Also, the keyword of later kind of implies a prediction there. And so this one would be our regression. All right, I hope you enjoyed that fun little mini quiz and the opportunity to practice thinking about how you would go from business question to identifying the right analysis to use with your data. And don't forget to tune in next time because we are definitely not done with all the things that it takes to be able to solve that problem with data. I hope to see you next time.